Math 102, Graphing Transformations. In this class, we're going to have a number of different ways that we can change our graph. The first is a vertical shift. So here, we're going to have our base function, which will be one of those library of functions. And then we're going to have a plus c at the end, which will move it up c units. So if I have x squared plus 3, I like to call something my base graph, or the shape, because that's going to be what gives it its shape, is the x squared graph. And let's just do that with dotted lines. There's my x squared graph. Now I've got plus 3, so I'm going to pick it up and go 1, 2, 3, and then graph. There's my function. Now for all of these, we can graph them on the calculator as well. So here, if we type in x squared plus 3 and hit graph, we do get basically the same shape. What happens if we've got a minus? So here, my shape is still that square graph, but this time I've got a minus 4. So I'm going to go down 1, 2, 3, 4, and then let's draw my square graph. Let's scroll down to look at my next one, which is the horizontal shift. Now we've got to be a little bit more careful about this one. Once again, I've got my base shape. This time, instead of adding or subtracting outside, I'm going to do it on the inside. And that means it's going to go backwards. Normally, plus means we're going to the right, but this time we're going left. So let's say I've got f of x is the absolute value of x plus 2. So my shape is the absolute value graph. And as we hopefully recall, that looks like the letter V. So there's my base graph. Now, the plus 2 means I'm going to go left 2 and then draw my V. Once again, I can use my calculator to help me out. Remember, to get the absolute value, I go to Math, and then I go to Num, and that very first option, ABS, is my absolute value. So x plus 2, make sure it looks correct in my equation, and then hit graph. And yes, that does hopefully look like we've moved left. Let's go the other way around. I've got the absolute value of x minus 1. So here, my shape is still that absolute value graph, but this time I've got minus 1, so I'm going to go right 1 and then draw the letter V. Let's scroll down again from our next type, which is the vertical stretch or shrink. Now, as far as the equation is concerned, both of these involve multiplying an a out in front. The only difference is what type of number is that a. If that a is greater than 1, we're going to stretch it vertically. Basically, we could make it skinnier. However, if a is a decimal or fraction between 0 and 1, then we're going to shrink it. We're going to make it look fatter. Please note that a is still greater than 0, so that means a is positive. A negative is going to be something different. So if I have 2 times the absolute value of x, my shape is that absolute value graph. Here's my absolute value graph. And here it's times 2, so I'm going to stretch this by 2. And I'm going to make it look approximately twice as skinny. The next one, I've got 1/2 times the absolute value of x. So here's my base shape, and this time it's 1/2. I'm going to shrink this. I'm going to make it look wider so that it will look something like that. Now, graphing by hand, I exaggerate these a little bit just so you can tell I've done them. On the calculator, you can always go to the table and get exact points if you're having trouble seeing whether or not there's a stretch or a shrink. My final type of transformation are reflections. I've got both x-axis and y-axis. These involve negative signs. If the negative is out in front, so it's the first thing we see, that's going to be an x-axis reflection. However, if the negative's on the inside, so it's within the operation, then that is going to be an y-axis reflection. These are a little harder to remember. I use the square graph to remember. So if I have a negative x squared with no parentheses, that is going to be an x-axis reflection. So I'm going to flip it down so that it looks like that. There's my x-axis reflection. But what if I have a negative x inside parentheses, and then I square the entire thing? This is a y-axis reflection. But what happens if I take that square graph and reflect it around the y-axis? Well, it looks exactly the same. And that's because if I take a negative and square it, it's like I didn't do anything. So that's how I remember which is which. However, if you graph them on your calculator, the calculator does know which is which. So when in doubt, you can always use your calculator. And these are our transformations.